A'udhu billahi minash shaitanir rajim. Bismillahir Rahmanir Rahim. Dear students, today our topic is, first of all, we have a definition. Let S be a non-empty subset of V. S is a non-empty subset of V. Then the subspace Ls of V, containing all the linear combinations of the element of S, is called the linear span of S, or a subspace generated or spanned by S. That is, Ls is a subspace containing all the linear combination of element of S and space generated by or spanned by S. Second definition: a vector space V is said to be finitely generated if there exists a finite subset S of V such that Ls is equal to V. V is finitely generated because S is a finite set which generate the vector space V. For example, the vector space V is equal to R cube is finitely generated because Ls is equal to R cube, where S is equal to a set 100, 010, 001. V is equal to R cube is finitely generated because S is a finite set. It contains three elements and it generates the all vector space V is equal to R cube. Similarly, we have second example. The vector space Rn is finitely generated because Ls is equal to Rn. For we have a finite set S is equal to 10000, comma 01000, comma 00001. This finite set S generates the vector space Rn. So therefore it is Rn is a finitely generated space. The vector space V of all the polynomials of degree less than or equal to n. All the polynomials whose power is non-negative is finitely generated because if S is equal to 1 comma t square dash 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 t power n, then Ls is equal to V because this set S generates all the polynomials of degree less than or equal to n. Fourth number, the vector space V of all the polynomials of any degree is not finitely generated because the set S cannot generate this space V. Now we next have a theorem. Let S and T be subsets of the vector space V. Then S is a subset of T. Implies that LFS is a subset of LFT. Proof: let V belong to LFS. Then there exist scalars alpha I in F and vectors Vi in S such that V is equal to alpha 1 V1 plus alpha 2 V2 plus alpha n Vn. We know that alpha 1, alpha 2 dash 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 alpha n are the scalars and V1, V2 dash 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 Vn are the vectors. As S is a subset of T, so Vi's are all the elements of T are also in T. Thus alpha 1 V1 plus alpha 2 V2 plus alpha n Vn also belong to LS LT. As LT is a subspace, so all the elements which are present in S is also present in T. Therefore, hence we can say that V belong to LFT, and so LFS is a subset of LFT because we belong to LFS and we belong to LFS and we also belong to LT. So this implies that LS is a subset of LT, which is required.